Today, we are working with a Honeywell flame detector. It's an ultraviolet detector for oven applications. This is mounted to where it can see or detect a flame out in front of it, and it's used for control of temperature. Basically, when an oven is too hot, it will know if the flame is on or off and send a signal out to a temperature controller so that it can turn the flame off. And if it's too cold, it can send a signal out to keep the flame on. This UV detection circuit allows an oven to regulate temperature and keep a certain set point constant. We'll give everyone a good look at the internals here. We've got the sensing tube, we've got the input wires, and the output. It can be used with other applications as well. That's anything detecting a UV source. So today, we're going to show the testing of this unit and its repair. We've got a few wires here that come out of the unit. The black and white wires are for the AC input voltage, which is 110 volts. And then we have our blue and yellow signal wires for seeing the flame. We've got our AC power going in. It's not on at the moment, but we have power going to it. And we also have our 20-volt DC supply, which also at this moment has no output. Now it is going to the ground reference, which is here. And then we have our input, which is here. Now we're going to attach an input to what is called a pull-up resistor. We're not going to be able to see the change in signal without this. And we have our oscilloscope probe here, which we are going to put the ground reference onto the setup here. So the ground reference is here. We're attaching the ground reference so then the oscilloscope can see what's going on. And we are all hooked up here. Okay, we have our UV lamp here and it is set to the UV mode. And we're going to go ahead and set the oscilloscope on the reference. We are going to attach the probe to it. And now we've got our DC supply on. The first thing we notice that indicates there might be a failure is, as we can see, it's not drawing any current here. This indicates something is wrong, but we'll go ahead and still do our test. What we see is our signal here. And when we press the lamp button, we should see a change as this UV goes to the aperture and is sensed by the unit. So we're going to go ahead and do that. And we see there is no change. We'll go ahead and take it away again. And once again, we see no change. Nothing happens. So this appears to be a dead unit in need of repair. Okay, so what we've discovered is over here. We have this transformer and the AC goes in on the primary side here. And on the secondary side, after it, we have these 4 diodes, which are a bridge. And we have seen these to be bad. So we're going to go ahead and remove them. We have the diodes here, 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 and here. It is important to ensure we have the correct polarity here. We've got everything prepared with the bridge. Okay, now we have our new cover on, a new gasket for the customer, and we are ready to do our test. So we have our ground hooked up, and we've also got the oscilloscope ground hooked up to the same place, as well as from the power supply. And we've got our power supply hooked up on the opposite side of this pull-up resistor. We've got our oscilloscope on the other side of it, attached to the flame detection signal wire from the unit. And this is what tells the unit that a flame is on or off by detecting UV or IR waveforms. So if this is successful, we've repaired it, and so we'll know that when the UV light comes on, the signal should drop like an on-off state. So we're going to go ahead and give some illumination, and we can see that the signal indeed has dropped. So we're going to turn the light off and then on, off, on. And we can see that we have a good signal showing the change in states while detecting a flame. this unit is repaired and ready to ship to the customer. For more videos, subscribe to our channel.